Okay, welcome to this short video clip on trigonometry and how to find the length of a side of a right-angled triangle. We're going to be going through three different examples and they relate to the video clips on Hegarty 509 and 510. The very first thing I want you to do is draw out this triangle, copy out the question, and write down these 5 instructions, because these 5 instructions are going to form the basis of each of the examples that I'm going to show you. For example 2 and 3, there will be 6, but these 5 will be in all of them. Okay, so pause the video now and do that. Okay, so as in the previous video, in 508, we said it's really important that we label our sides correctly. Okay, and before I even read the question, that's my first step. I want to label the sides correctly. Okay, so I know straight away that that is the hypotenuse. We've been given an angle, so we know that this is the opposite. Okay, and we know therefore that this must be the adjacent. Okay, now I haven't finished labeling my sides yet, because now I'm going to read the question. So it says that y is 4 centimeters. So I can also write that in. Now there are a lot of labels here. It's really important we pick out the right one. So the adjacent is 4 centimeters. The angle of theta is 42 degrees. Okay, and are we given anything else? No, we're not. And it's told us to work out x rounded to 1 decimal place. Well, that's here. Okay, so that's what I'm looking for. Right, okay, so we've labelled all our sides. Okay, now we need to work out which sides it is that we want to use. So to do that, I'm going to write out that mnemonic that we learned in the previous video, which is Sohcahtoa. And I'm always going to write this out. Okay, so if we look at the question, I want to work out x. Okay, so x is there, x is the opposite. Okay, now the other side that I'm going to use is one which I know. Okay, I don't know what the length of the hypotenuse is, so I'm not going to use that. So I'm going to use the adjacent, because we've been given that side. So that's A. So I've got O and A. So which ones use O and A? It's tan. So I'm going to circle that one. That's the one I want. I'm going to write out the ratio, which is that the tan of the angle is equal to the opposite over the adjacent. So we've determined which sides. Now this next bit can be a little bit tricky. Okay. Which side are we looking to work out? Well, we are looking to work out x, which is the opposite. So I want the opposite on its own on one side of the equal sign. At the moment, it's being divided by a. So to get rid of that, we're going to multiply both sides by the adjacent. So it's going to become a tan of the angle equals the opposite. Okay, because remember in algebra we don't write the multiplication sign, so adjacent multiplied by the tan of the angle equals the opposite. Okay, so we've rearranged it. I've got the opposite on its own on one side of the equal sign. Tick that off. Step 4, substitute in the values. Right, okay, so let's do that then. So let's start with the adjacent. So the adjacent was 4 centimeters, so it's 4 tan. Really important that we add in some brackets here, so the calculator will do that for you when you type it in a moment. But tan, now theta was 42. Make sure we close the bracket, equals, and that will equal the opposite. So we've substituted in our values. The last thing to do is to type that into our calculator. So we're going to type it in exactly as we see it. So 4 tan 42, close the bracket, equals, and we get an answer of 3.601. centimeters. However, if we look back to the question, it wants it to 1 decimal place. So our final answer is going to be 3.6 centimeters. I'm going to underline that twice to signify that that is my answer. Okay, so that's how we're going to find the side of any right angle triangle using trigonometry with those 5 steps. Doesn't matter whether we're using sine, cosine, or tangent. Okay, we're using those 5 steps, and using those 5 steps you'll be able to clearly see which one of those trigonometric ratios you will need to use to work out the length of a side. Okay, so that's video clip 509. Now 510, as asked relating to that, you are asked to work out the lengths of sides again, but this time the triangle hasn't been drawn for you. You've got to do that, so that's an extra skill in itself. So we're just going to look into the language, the mathematical language of this question here as an example. So it says that A, B, and C form the vertices of a triangle, vertices being corners. Okay. Angle CAB equals 90 degrees. Angle ABC equals 57 degrees, and AC equals 8.9. Work out BC to 3SF. Okay, there's a lot of letters in there, so let's dissect them. Okay, so A, B, and C. Vertices are corners, so those are the corners of a triangle. So what I'm going to do now is I'm going to draw a triangle. It's the very first step. So I'm still going to use the same 5 steps as before, but this time, before I can do that, I've got to draw a triangle. And because it's trigonometry, and because I can see there is an angle of 90 degrees, I know there's going to be a right angle in there. Right, now, start with the second line. Angle CAB equals 90 degrees. Now what that means is if I go from C to A to B, that angle will create 90 degrees. So the letter that goes where that angle is, that 90 degrees is the middle letter. So that's going to be A. Now, the other angle, it doesn't actually matter where I put it, so long as I label it correctly. Now that angle is 57 degrees, and it says that A to B to C equals 57. So I'm going to start at A, I'm going to go to B, and then I'm going to go to C, and the angle created by doing that will be 57 degrees. So the letter in the middle is 57, so that's B. Which makes that angle up there C. Okay, so if I go from A to B to C, the angle that's created in between those 2 lines is 57. Okay, so that's the first step. Now we're going to do exactly that 5-step process from before. Let's label our sides. So the hypotenuse, opposite the right angle. The opposite, which is opposite the angle that we know, and the adjacent is the one that's next to it. Okay. The other bit of information we're given is that the line AC, if I start at A and I go to C, is 8.9. It doesn't give units, it just says that it's 8.9. Okay, so we know the opposite is 8.9. Okay, so we've done step 1, we've labelled our sides. Our next step is to work out which sides we need to use. Okay, so we need to work out what BC is. So we're looking at BC. So we're going to be looking for the hypotenuse. Okay, because if we look out for, if we write down our mnemonic as we did last time, Sohcahtoa, we're going to be using the hypotenuse. The other side we know is the opposite, so I'm looking for one which has got opposite and hypotenuse in it, which is right there. Okay, so the S, that's sine. So the sine of theta is equal to the opposite over the hypotenuse. Okay, So we've done step 2, we've worked out which sides we're going to use. Step 3, let's rearrange it. We're trying to work out the hypotenuse, so we want the hypotenuse on its own on one side of the equal sign. It's a little bit complicated because it's at the bottom of this fraction. So the first step is to get it off the bottom of the fraction. So we're going to multiply both sides by the hypotenuse. So it's going to become hypotenuse multiplied by the sine of theta equals the opposite. But the hypotenuse is still not on its own on either side of the equal sign. Now remember, this is hypotenuse times the sine of theta. The opposite of times is divide. So we're going to divide both sides by the sine of the angle. So the hypotenuse is now equal to the opposite divided by sine theta. And the very last, the fourth step was to substitute in our values. We don't know what the hypotenuse is. We know what the opposite is, it's 8.9. And we're going to divide that by the sine, don't forget our brackets here, of the angle, which was 57 degrees. So the hypotenuse, if we type that into the calculator now, the first thing I'm going to do is I'm going to use the fraction button on my calculator, which is just here. And then I'm going to type in my value. So the opposite, which is 8.9. And then I'm going to divide that by the sine of 57, close my bracket, really important, equals, and I get an answer of 10.612, and it wants it to 3 significant figures, so my answer is going to be 10.6. And that's my final answer. Now our third example, again, we're going to use the same 5 steps as a basis, but this time what we're looking at is not a right-angled triangle. This time we do have an isosceles triangle, and we've been given some information. We've been told that angle ABC is equal to 34 degrees. So if I go from A to B to C, the angle that creates is 34 degrees. So that's that angle there. That's 34 degrees. Now, because this isn't a right angle triangle, I don't have a hypotenuse, an opposite, or an adjacent at the moment. But there is something I do know about these types of triangles, and something you will know as well. That's if you split them down the middle, like so, this angle at the top here gets cut equally in half. So this angle now is 17 degrees, not 34. These lines, they mean that those two sides are the same length, so this is also x. It also means that this line has been chopped exactly in half as well. And what it's done is it's created a right angle there as well. So now we have 2 right-angled triangles. And because this is starting to look a little bit messy, and because I don't need both of these, I'm only going to draw out one. So I'm going to redraw one of my triangles. Right angle is there. We know that that is 17 degrees. And we know that this is x centimeters, which, if we're going back to labeling correctly, our first step, we know that that is 10 centimeters. Right, so let's label the sides correctly. Hypotenuse is opposite the right angle. The opposite is opposite the angle. the adjacent is next to the angle. Okay, that's step 1. We have labelled our sides. Okay, step 2. Which sides do we need? Well, let's write out that mnemonic again. Sohcahtoa. Right, now, because in the original question it says find the length of AC, well, I want to go from here to here. That's the whole length of the bottom of the triangle. Now, I've only drawn out half of that original triangle, so I want to work out the bottom here, and because these two are equal, I'm going to work out the length of this here from A to the midpoint, and then I'm going to double it. So that would be the opposite. So I know I want the opposite, because that's what I'm trying to work out. The other side that I want is one that I know. Well, that's the hypotenuse. So I want opposite and hypotenuse. So opposite and hypotenuse, there they are. So that is sine. So I want the sine of the angle is equal to the opposite over the hypotenuse. Okay, step 3, rearrange it. So we want to work out the opposite. Let's get rid of the hypotenuse here. Let's multiply both sides by the hypotenuse. So it becomes hypotenuse times the sine of the angle equals the opposite. Step 4. Should be getting rather familiar by now. We are going to substitute in the values. So the hypotenuse is 10. So it's 10 sine, don't forget our brackets, 17, which equals the opposite. And we're going to type that into the calculator as we see it. So 10 sine 17, don't forget to close your bracket, equals, so step 5, we're on calculate. And that gives us an answer of 2.9237 and a few more numbers after that. Now, what's really important here is that you don't round anything. You leave that answer in your calculator. And it'll become clear as to why in a moment. So what we've worked out at the moment is this length here. We've worked out from the corner here, which is labelled A, to the middle of the line AC. So we've worked out this distance from A to the middle of the line AC. But we need to double it because we also need to go that distance again. So what we're going to do is we're going to take this answer that's still in our calculator because we haven't done anything, and we are going to type into the calculator the following. I'm going to show you. So we're going to press the answer button at the bottom of your calculator here. We're going to press answer times 2 and the equals button, and it will give us an answer of 5.847. Okay, so AC equals 5.847 centimeters, and it's asked it to 1 decimal place, so let's get the accuracy in there. So the line AC is 5.8 centimeters to 1 decimal place. There's a lot of information to take in over this video. Okay, so please pause at any point that you need to, go back and rewatch things and just take it step by step by step.